Welcome dear students. Now we can discuss the reaction as well as the mechanism of Reimer-Tiemann reaction. The reaction is well known and you know that in Reimer-Tiemann reaction, phenol, when we are treating phenol with chloroform and alkali, chloroform and sodium hydroxide or KOH we can use. In presence of chloroform and alkali at a temperature of around 70 degrees Celsius, phenol converted to orthohydroxybenzaldehyde plus parahydroxybenzaldehyde. This is what is called a Reimer-Tiemann reaction. So we have phenol reacting with chloroform in presence of alkali at a temperature of 70 degrees Celsius. You will get orthohydroxybenzaldehyde as well as parahydroxybenzaldehyde. That means salicylaldehyde is the major product. This is a major product. Salicylaldehyde or orthohydroxybenzaldehyde will be the major product and parahydroxybenzaldehyde as a minor product. Now we can see the mechanism. The mechanism involves an electrophile, which is the electrophile here, dichlorocarbene. Dichlorocarbene is the electrophile and it involves electrophilic substitution reaction. The mechanism is electrophilic substitution. The mechanism actually involves 4 steps. We can write mechanism in 4 steps, and actually as we have already mentioned, the mechanism, the reaction is electrophilic substitution. Electrophilic substitution of electrophile, which is the electrophile here, dichlorocarbene. Here carbon atom is electron deficient, so it is acting as electrophile. So electrophilic substitution of dichlorocarbene to aromatic system, to phenol. Okay, so this is a reaction take place. And in the mechanism, in the first step, base is reacting with the chloroform and it's going to form dichlorocarbene. So the formation of dichlorocarbene can be written in 2 steps. In the first step, CCl3 minus is formed. In the second step, actually from CCl3 minus, one chlorine gets eliminated and you will get CCl2. So, or you can write in a single step formation of what? Dichlorocarbene, or in the second step we can represent the formation of, when this Cl is eliminated, you will get, Cl is eliminated as Cl minus, is it? So you will get CCl2 and this is nothing but dichlorocarbene, and which is the strong electrophile. It's an electrophile plus what? Cl minus. Okay, so either you can write in a single step OH minus plus CHCl3 reversibly gives CCl3 minus first, which reversibly gives CCl2 plus Cl minus. So 1 or 2 steps we can represent what? The formation of the electrophile dichlorocarbene. Okay, then in the third step you will have the reactant, that is nothing but a reactant, phenol. Okay, so phenol in presence of a base, it will exist as phenoxide ion. Okay, because you know that phenol is acidic, so it easily releases H plus, is it? So in presence of a base, it releases H plus very easily, and phenol is existing as phenoxide ion. So it is better to represent, or you have to represent phenol in the phenoxide form. Okay, phenol can be represented in the phenoxide form. Here phenoxide ion, so this is phenoxide ion, CH5 minus. So phenoxide ion is combining with our electrophile dichlorocarbene. Okay, so you can write the third step phenoxide ion, is it? Phenoxide ion is reacting with dichlorocarbene. And this you can written as irreversible manner. Okay, then what happened? This dichlorocarbene will attack this benzene. Okay, and 1 second, you can have the structure like this. Using this lone pair. Okay, using this lone pair, because this is electron deficient species, is it? Dichlorocarbene is electron deficient, therefore 2 dichlorocarbene bond is formed from towards dichlorocarbene. Pi bond is used, and you will get what? As a result of this, you can have oxygen. Okay, then one lone pair is used, is it? Double bond here, double bond here, and it becomes CCl2. Okay, but we know that hydrogen is here. Okay, CCl2 minus. Then in the next step, the CCl2 minus easily converted to CHCl2 by getting an H plus. Okay, so this electrophile, okay, so in presence of water, what happened? This CCl2 minus becomes CHCl2. Okay, so you have to write that. How will you write that step? Yeah, CCl2 minus becomes CHCl2, that you have to remember, in presence of H2O. Okay, and H is there, double bond O. So this is a change. CCl2 minus converted to CHCl2, and in the next step immediately benzene ring is formed. Okay, how it is formed? Yeah, it's formed as okay, so you can write what will be the product. Yeah, CHCl2, and it becomes what? And H plus is released here, is it? Minus H plus. ഇവിടെ നിന്നൊരു H plus പോയിട്ടുണ്ട് ഈ ഇലക്ട്രോൺസിനെ റിംഗിലേക്ക് കൊടുത്തിട്ട്. So that H plusഉം ഈ O മൈനസും കൂടെ ചേർന്നിട്ട് you can write OH. Is it? So this is the third step. So phenoxide ion is used. Okay, from phenoxide ion a bond is formed, and a slight it becomes CCl2 minus because an extra electron. Okay, it becomes CHCl2 and phenol with CHCl2. Okay, that is a third step. In the fourth step, in presence of base. Okay, you know that in the third step, what? CHCl2 is in the ortho position, and that was the product of third step. In the fourth step, in presence of strong base, what happened? Actually, from CHCl2, what happened is that 2 chlorine atoms replaced by OH. Okay, so CHOH like that it comes, but you know that that is unstable, and readily it is converted to aldehyde. So as a result, you can write that is actually takes place. So to this system, what? Yeah, OH, and it becomes, and you know that in presence of base, phenol is existing as phenoxide ion, is it? Therefore, because whenever base is there, H plus is released. Okay, so it is better to represent O minus rather than OH. Phenol എന്നുള്ളതിനെക്കാട്ടിലും phenoxide ion ആയിട്ട് കാണിക്കുന്നതായിരിക്കും നല്ലത്. And it converted to CHCl2. ആദ്യം CHOH twice ആണെന്നു അതിൽ നിന്നാണ്. So it is converted to CHO. But in presence of H plus, you will get the product. Okay, and this is the mechanism of Reimer Tiemann reaction. Okay, and this is ortho hydroxy benzaldehyde. So it is a major product. So if we want to represent para, then it is better to attack, is it? നമ്മൾ third സ്റ്റെപ്പിൽ കാണിച്ച പോലെ O minus, is it? Phenoxide ion, and that can be used like this. And using this bond pair, CCl2 can be linked. So in that way, para hydroxybenzaldehyde also can be formed. So this is the mechanism of Reimer-Tiemann reaction. So you should write and learn. Okay, hope it's clear. Using textbook, you have to take notes also. Thank you.